So we want to continue with our operation on sets, and if you remember, we stated that assuming you have two sets, example, let's say we have 2 with 3, and that is multiplying 3 with 5. What we do is that the numbers will multiply themselves and the sets will also multiply themselves. So we will have 2 multiplying 3. So the product of that will be having root 3. That's one also multiplying root 5. So the outside product or the coefficients are going to be 6, 2 by 3, and this will give us root 15. Note that what we had here is the product of 3 and 5. That is what gave us the 15. The product of 2 and 3 gave us 6. So that is what we did previously. Now we want to continue by looking at addition and subtraction, then after which we will look at division. Now in algebra, assuming you are asked to add some terms or monomials, for example, if you are given 2x, so 2x plus 3x. If you are asked to simplify this, note that since both monomials, this and this, have the same variable, we term them as like terms. So these are like monomials. So in that case, if you want to add, what we do is that we can decide to factorize our x out, and so we will be left with 2 plus 3 inside here. So the sum of 2 and 3 will be 5. So that's multiplying our x outside. So that multiplying our x outside should give us x times the 5 in the bracket. So that should give us 5x. So what we mean by this is that assuming you have 2 oranges and then 3 oranges, how many oranges do you have? So this is the idea in algebra. So you have 2 oranges, that is 2x, where x represents orange, then 3 oranges. So how many oranges do you have now? You know we have what? 5 oranges in all. That is the idea. So if you are asked to, let's say, add sets, SURD, you need to identify whether the sets are like. So for example, 2 root 3 plus 3 root 3. These sets can be classified as like because we have root 3 here and root 3 here. So when that happens, the easiest thing we can do is that we can decide to factorize our root 3 out. So when root 3 is factorized outside, note that we'll be left with 2 on the left hand side and we'll be left with 3 on the right hand side. You know we are doing factorization, so you have 2 plus 3 giving us 5, so that should give us 5. Then we also have our root 3 outside here. Now note that since 5 is going to be the coefficient, we can decide to bring it to the front to make it more appealing. So in that case, what we have is the sum of 2 root 3 and then 3 root 3 should give us 5 root 3. So the idea is that anytime you are asked to simplify an expression which involves sets, So for example, 2 root 7 plus 3 root 3 minus 4 root 7. Right. So we are asked to simplify this. In that case, what we do is that we group them into sets. Like sets. And over here our like sets are going to be this and this. So we bring them closer to each other. So we have our 2 root 7 minus 4 root 7 plus 3 root 3. Note that in this case our 3 root 3 is not a like set to any of the two, right? So in that case, the next thing we do is that we treat them as a variable. So you can decide to treat this root 7 to be like x. So you have 2x minus 4x. But in real terms or in proper terms, you can decide to factorize because we have root 7 here and we have root 7 here. So if I decide to factorize, then we are going to have 2 minus 4 in the bracket. Root 7 will come outside. So root 7 will come here. And then we have plus. The next set is 3 root 3. But note that we have not finished with this, the first part. We have not finished with the first part. The first part is 2 minus 4, which is giving us negative 2 root 7. And we have plus 3 root 7. Now 3 root 3, I beg your pardon. So 3 root 3. 3 root 3. Because we have, this is what I was trying to write. So it was a mistake. So our final answer is going to be negative 2 root 7 plus 3 root 3. Now we can't do anything about this because our root 7 and our root 3 are not like. So this is the final answer. But many times they would expect that you write the positive number first or the positive set first. So they will expect you to write something like 3 root 3 minus 2 root 7 as the answer, as the final answer. Right. So let's pick another example and see what we can do, how we can treat it. So assuming you have 2 root 20 plus 5 root 40. Now note that this set, what we have here, is not in its simplest form. So what we do is that we have to simplify them. So in order to simplify, what we do is that we express them in the form that we have already stated. Now note that our 2 is outside here and our root 20 can be expressed in the form root 4 times root 5 plus our 5 is outside, this 5, times, when we express this, we have root 4 times root 10. So we simplify the first part, then also the second part, then we bring them together. So the first part, remember 2 is outside, so 2 is outside. Inside here, root 4 will give us 2, and root 5 is still root 5. Plus, let's come out here and see what we have. What we have here is that we have 5 outside. Then inside here, root 4 will give us 2. then root 10 is still root 10 because we can't do anything about that. Now what we are left with is taking 2 against 2 and 5 against what? 2, because what we have here is a constant. It's a constant that should multiply a constant. We don't have any root 5 in the outside term, neither do we have root 10 in the outside term. So 2 will multiply 2 to give us 4 root 5, and that will be added to 5 times 2 to be 10 root what? 10. Now at this level, you see that root 10 and root 5 are not like terms, so we cannot do any more operation about this. So this is the simplest form we can express this kind of example. So in essence, what we are saying is that assuming you have a set A root B and you are adding it to another set M root N, what we are saying is that if A and B, for A and M, there are no issues. But to be able to add these two sets, consider the set, the one under the radical sign. If they are the same, that is, if B is equals to N, then it means that you can add the A and M. But in this case, because we have root B and root N, both of them are not equal. So in that case, we can't do anything about this. We can only leave it in this form, right? But in the case where we were to have something like A root B plus M root B, because we have root B, what we can do is that we can decide to add A plus M, and that will be multiplying one of the root B. What it means is that we have factorized root B out of the terms, so we have sent it outside, and when it goes outside, it can come back and multiply the A to give us the first term, and also multiply the M to give us the second term. So in essence, if the sets are like, then it means that we can add the coefficients. If the sets are like, for example, if we have 2 root 3 plus 3 root 3 like we did earlier, what we can do is that we add 2 and 3, then we multiply it one of the sets. So in that case, we have a 5 root 3. So that is what we did. What we did is that we factorize the root 3 out, because root 3 is here, it's also here at the same time. So what we did is that we factorize it out. So when we factorize, we had root 3 coming out, and then the coefficients are added, which is 2 plus 3 to get 5. Then we multiply it with the root 3, which is the final answer. The same way, if the sets are like, then we can also subtract. So in that case, if we have something like M root N minus, let's say, A root N, because we have root N, what we can do is that we can subtract the two coefficients and multiply it with one of the n's, one of the root N, right? So because these sets are like, we can do that. But assuming we were to have something like 3 root 2 minus 2 root 3, these sets are not like. So because of that, we cannot do anything about it. We cannot write this. If you write 3 minus 2, you will not be able to tell whether you should put root 2 here or put root 3 there. So in this case, since they are not like, we cannot do anything. This is the simplest form we can express it. So the simplest form is the question itself, minus 2 root 3. We cannot do anything about it, and this is the simplest way we can leave this expression, right? So Let's quickly look at division. So we have talked about addition and subtraction, multiplication. Let's talk about division. Now, assuming you have two sets, which, for example, we have root 15 divided by root 5. So over here, what we do is that we extend the division sign like this, then we put the two numbers inside, just like we did for the multiplication. So in this case, we have 15 divided by 5, and that should give us 3. So the answer should be root 3. Note that the root sign is still there, so don't forget it. If you forget it, you are getting it wrong. Right. So if you are given root 20 divided by, let's say, root 5, what it means is that you're going to extend the division, the root sign, and then write the top number, which is 20, that will divide the bottom number, which is 5. So over here we have root what? 4, because 20 divided by 5 is 4, and that should be 2. So this should be our final answer. Right. So in simple terms, if you are talking about generalization of the sets in division, then what we are saying is that assuming you are given a set, let's say question 1, you are given a set root A on root B. Then if you want to divide it, what we do is that you extend the division sign and bring your A and bring your B, and the answer that you get out of this should be the solution for the question. Yes. So in short, these are the basic operations that we can operate when it comes to the set. Now there are some instances where you can be asked to evaluate some sets which are not in the form that is familiar. Yes, which are not in the form that is familiar. For example, you can be asked to evaluate a set. For example, a set that so for example, you can be asked to simplify a set like 2 minus root 2 to the power 2. Now, if you remember your class in the Pascal's triangle, we started by saying that you can decide to use Pascal's triangle to evaluate this or to simplify this. In another perspective, you can also use the combination approach, yes, to do it. But what this means in simple terms in this aspect is that it means that 2 minus root 2 is multiplying itself 2 times. So what we do is that we write 2 minus root 2, and that is multiplying 2 minus root 2. So it's multiplying itself 2 times. At this level, you can decide to use what we call the FOIL method or the spread method. I remember we treated this in class. So to use the spread method, you people like the spread method. What we do is that we pick the first term in the first bracket. So we put 2, and that will multiply 2 minus root 2. That is the second term, right? So we have negative here, so we put a negative there. Then pick the second term in the first bracket, which is root 2. That will multiply this whole term again, which is 2 minus root 2. Right. I believe you are following. So what we do next is that this time around, this 2 multiply this again, will come and multiply this term. Then this will multiply this and come and multiply this again. So 2 will multiply 2 for the first time. We have 4, right? Then 2 times, remember there's 1 here, but we don't write it. So 2 times 1 root 2. So, and remember there's negative there, so we put our negative. Then we have 2 root what? 2. Then we come and pick this, the second part of the equation or the question, which is root 2 times 2. Remember 1 is in front here, so easy to multiply. But note that initially there is also negative here. If you don't take care, this negative is there, it will confuse you. So you bring a negative first and bring out 2 root what? 2. The next one is that we have negative here, so let's bring a negative. Let's bring our negative, and we have root 2 multiplying root 2 again. So root 2 times root 2 will give us what? What it means is that if you want to simplify it, what you do is that you can decide to pick, sorry,